In this tutorial, we're going to develop an exercise about how can we calculate the loads over the columns due to overturning moments produced by seismic loads and P-delta effect. The overturning moment is an effect created by the push of the lateral forces on the structure that try to overturn the building and generate axial loads in tension or compression on columns depending on the location of the center of gravity of the sections of the column from each frame of the building. To calculate the axial load due overturning moment, we do with this equation, where P is the axial load transmitted to the columns, Mx is the overturning moment, ICG is the moment of inertia of each column based on the center of gravity of the frame, Cg is the distance from the columns analyzed to the center of gravity of the frame, and Ax is the gross area of the column. The overturning moment is calculated with this equation, where Fi is the lateral force of the story in static, and Hi is the height of the story measured from the base. In this case, for roof story is its lateral force by 480 inches, for structural floor 3 is its lateral force by 360 inches, for structural floor 2 is its lateral force by 240 inches, and for the structural floor 1 is its lateral force by 120 inches. The center of gravity of the frame, Ck, is calculated with this equation, where Ax is the gross section of the columns and L is the distance from a convenience point of the center of gravity of the column. For example, for this building, AC1 by L1, AC2 by L2, and AC3 by L3. The moment of inertia of the column is calculated with this equation, where Ax is the gross section of the columns and Cg is the distance from the columns analyzed to the center of gravity of the section of the columns. In this example, we are going to simulate that the stability coefficient in the structural floor 3 is over 0.1 and make the corrections on the lateral forces to include it in the calculus of the overturning moment of the building. We are going to analyze the frame A. The dimensions of the columns of the frame A are corner columns 12 by 12 inches and border columns 12 by 14 inches. The first thing that we're going to do is calculate the incremental factor as requested in the section 12.8.7 of the American Society Civil Engineers Standard, that we're going to multiply each lateral load of each level. The result of equation has an incremental factor of 14.7%, which multiplied by the lateral force of the roof story results in 43,890 pounds. In this frame are tabulated the lateral force corrected for each story. With the lateral forces for each story corrected, we calculate the overturning moment of the building. The summation of the moment results in 3,690.87 kPa-feet. Now we calculate the center of gravity of the frame by multiplying the area of the column by this convenience point, resulting in 16.78 feet. After that, we calculate the moment of inertia of the columns based on the distance from the center of gravity of the section to the center of gravity of the frame. The summation of the inertias results in $584.87 square feet. Finally, we calculate the axial loads transmitted to the columns due overturning moment, given for this column 105.88 kilopounds. In this frame is tabulated the axial loads due overturning moment on columns, 2 works in tension and 2 works in compression. With this conclude this tutorial.